Well, hi, good morning, and thanks so much for joining me here in my shop. Hey, today is August 19th, and proving to be another sunny day, but much cooler here now, so great. But I'm in my shop, and we're looking at 3 more speakers to test. That's right. So I've been in the sort of speaker testing mode for the last couple of days. This is the radio I've been working on for, I don't know, a week or so, on and off. And so this is typical of these European radios. They have speakers at the sides. What's not typical, well, there's a lot of things that I don't understand about this set of speakers. So let's go through it. I'm going to look at the schematic and try and sort out what they're really trying to do, because there's some elements here in the circuitry that not making a lot of sense to me. So first of all, look at these wires here. So when these are connected back to the radio, it certainly looked to me like 2 black returns, a yellow feed to this and an orange feed to this and this. But in fact, I discovered that back in the radio, these 2 black wires are simply tied together and don't go anywhere. They're just tied together. So the signal is actually fed in to the orange and the yellow wire, which is really counterintuitive, totally counterintuitive, because that puts these speakers kind of in series, kinda. So another thing is there's a coil here. It could be more than a coil. It could be a capacitor inside there too, but there's a coil here and it's paralleled, or it's in parallel with this speaker. Therefore it's in parallel with this one too. But this speaker doesn't have at all that arrangement. It's got more coils. There's a coil right here and a coil right here. 2 coils. A coil on each feed wire. Yet these speakers look identical. You know, why the different wiring system, or is what they've done, even though the components are distributed, really the effect is the same on both these speakers? Yeah, I don't know. I don't know about that. Is there anything going on with this one? No, straight to the voice coil here. So let's go from here to the schematic. See if we can add to the confusion here. Okay, so the part we're interested in is happening over here. I'm going to zoom in on it. So it's showing a lot of speakers, but this schematic is for a number of different radios. So over here it gives which speakers go with which radio. I have the Traviata on my bench. So that's V, 22, 25, and 26. 22, 25, and 26. If you notice, the wiring for these are in dotted lines. So maybe they're trying to help a little bit with looking at the schematic and realizing what's happening. I find this schematic, the way it's drawn, to be enormously confusing. I'm sure the person who drew it understood exactly what they were trying to communicate, but for me, this is massively confusing. So let's start with the output of this transformer. So this leg is not used at all in the radio I have. It's just from here and from here. You can see there's a circuit through this coil, through the speaker, and back. So here's one clear circuit. And this coil is affecting what reaches this speaker. This coil will be choking off the higher frequencies from reaching the speaker. Now here's the part that I had to look at this for a long time to realize it. These 2 speakers are connected across this coil. So the signal that is being blocked, if you like, by this coil is building up across the coil. So the treble is building up across the coil, and they're grabbing it and sending it off to these smaller speakers. Where's the rest of these now? So yeah. So this coil is the one that is positioned across this speaker. It's not, it doesn't look like it's here, it looks like it's across this speaker. How can that be? Because if you trace the wires here, you can see that in fact it is essentially across this speaker. So if you think of it as the lows will bypass this speaker. It's another way of viewing this whole arrangement. That the lows will go through and reach this speaker. The lows are bypassing around this speaker. These speakers, these two speakers. So again, if you look at the way he's drawn this, he's made it unnecessarily difficult to recognize what's going on. I find, anyway, that these two speakers are in parallel. This one, though, has these two coils all by its lonesome. Or are these two coils having an effect on this one, too? I just don't think so. And what would they be there for, and why would you use two? Why not just one coil? Why two? So I'm going to guess the reason for two here, one on either side of the speaker, is to maintain a certain, to maintain the correct phase relationship between this speaker and this speaker. I don't know if that's really true or not, but I'm thinking if you just had one coil, there'd be a phase shift, which brings up an interesting question, but there would be a phase shift between these two speakers, and that might be annoying to hear. They're on either side of the cabinet. A slightly out of phase signal may make you hear both speakers when you're supposed to just hear one, one central sound. So the phase thing is an interesting question. If these are being fed by the cast-off from this coil, wouldn't these be out of phase with this guy? Now that might not matter much if the sound coming out of these speakers is not identical. So the lows are coming out here and the highs are coming out of these, and there is no common area where the same sound is coming out of both. Well, that's nonsense. There's bound to be some overlap in these speakers. It's just interesting that how they've done it here. Maybe I'm completely wrong again about this, and perhaps this is the result of an awful lot of experimenting around in their own labs and discovering that all this works fine. I don't know. So what I'd like to do is feed a signal into these speakers. I'll feed a single frequency into the speakers, and then we'll look at the response of all three of these speakers with different frequencies being fed in. See if we can spot some kind of difference. The other thing that makes it, why would they put these coils in here? Well, to further restrict low tones from reaching this speaker. But they don't care about this one. And this would make this speaker different than this one. So you'd have a woofer, if you like. A little generous calling this speaker a woofer. It's not that big. Woofer, mid-range, and tweeter. There doesn't seem to be any reason in the world why that would be the thing to do, to me. Yeah, I don't get it. So let's see if we can get it by doing some tests on it. Well, let's see if I can get it. Can I get it? That's a good question. So we're going to use the signal generator here. Now, I don't think there's anything wrong with these speakers, or defective about them. Don't know. But generally, speakers, my experience with them is that they're surprisingly rugged. In that, you have a paper cone. And yet here they are, 60 years, 70 years later, still in fairly good shape. Kind of surprising. Okay, so the first thing we'll test this guy out first. Let me just make sure I'm hooking an 8 ohm speaker up to my piece of equipment there. I have no matching transformer involved. I don't honestly know the output impedance of this, but if it's a good instrument, it'll be very low. So it shouldn't matter doing this. And let's see if we hear anything. Oh yeah. So now that's a high frequency coming out of the low frequency speaker. So it can reproduce it, what frequency are we listening to? We're listening to, oh, we couldn't be 10,000? 10,000. Yeah, I guess that could be 10,000. I'm just gonna, just on the basis that, it's worth realizing this. I'm just putting on my own headphones here. Can you even hear that? Well, that's funny. I put on the headphones. I don't hear the tone. Okay, let me drop the frequency here. First, I'm having trouble as usual. Listening with headphones. Well, the speaker's right here in front of me too. You can hear that in the headphones. Look at my. So I have audio indicating meters here to try to keep me from talking too loud. Let's see what those guys do. Let me just jack this back up to 10. Yeah, I hear that in my own ears. These are not responding. So maybe it's exactly what I'm about to demonstrate, so I'm going to carry on here. What I was noticing was, as I move around in my shop, the sound is going up and down all over the place between my ears and stuff like that. High frequencies like this are bouncing everywhere. There's all kinds of interference patterns. The wavelength's fairly short, so you don't have to move too far to move through these standing waves or whatever it might be. So I'm going to just make the microphone swing, and we'll see what it sounds like. Swing, Mike. I absolutely don't hear the tone in the headphones. We'll put it at 5 kilohertz here. I'm moving around. So now that interference effect is not nearly as distinct. Okay, I'm going to lay off that. I don't know why. Well, you know what happens sometimes. I really have to watch my own video to find out what really came through. I'm sure you can hear 5,000 though. And what do we want to do now? So I'm just going to take the 5,000. I'm going to move it onto these speakers. Well, it sounds exactly the same, doesn't it? Well, this is the thing about sending a pure tone, is it doesn't reveal a lot to a human being. Now, I'm going to grab another microphone here. So experience has showed me that this microphone has a really good range on it. Okay, let me just turn up the volume on it. I'm going to turn off the others. Turn on this one, so now you're listening to me through this. Turned off. You can't hear any of that. Good. Okay, so what's the difference between these two speakers? Let's see if I can hold the microphone in a consistent way with 5,000 hertz feeding them. A lot louder over here. Let's take this up to 10. I'm going to stop at 8. Okay, here we go. It's on the same there. Now we got to do this with a little more. We got to put a little more into this. I'm going to get a piece of analysis software up on the screen here. And let's see. Okay, just 1 second. Okay, here we are. Let me just first make sure that we're listening to the microphones. Okay, switch it on. Okay, there's my voice. And now, so the image, this image here, I'm going to move it up to the top corner of the screen here. Just bear with me a moment. Okay, that's a little better than I had it my last video. Now, You can see the signal there at 8,000 hertz. I'm going to put the microphone central between the two speakers. Yes, it's behind them, but that's okay for now. And switch to this microphone again. Now what am I going to do? This isn't going to work. I was going to switch from speaker to speaker, but I can't. They're wired together. So that's a dumb idea. So I'll just move the microphone. That's at minus 30. Minus 36. Wave interference. Yeah, so you really can't compare, because again there's standing waves and all kinds of interference going on here, unless everything is done exactly the same. Okay, let's do it exactly the same. So I'll put this up. Just turn down the sensitivity a little bit. It's just below 30. It's at 36, so it's lower out of here at 8,000. Let's go a little higher here, even if you can't hear it. The microphone can still hear it. Okay, let's try here. 10,000. 10,000. Wow. Okay, so I think I got a dead center. I think I have a dead center there, but wow, the position of the microphone's a big deal, isn't it? .36, highest. This isn't very good. Much lower. And I was thinking these coils would be passing the highs. This would be the tweetery, the mid-rangery. That doesn't seem to be working out like that. Let's go down in frequency here. Okay, we'll try 3,000 hertz. That's potentially they want the 3,000 to go here, but we don't know. Maybe this isn't valid at all, what I'm doing here. Because maybe this speaker has to be in the circuit to make the overall impedances work properly, to make the distribution of the highs and lows work properly. So what I'm going to do, I'm going to hook this speaker up with these ones. Stab myself. Nobody else here to stab. Okay, so this is the way the radio does it. Feeds the signal in like this. I think maybe, I don't know what to think. So we're at 3 kilohertz. Well, just for what it's worth, 3 kilohertz. Minus 24. Minus 24, and then out the front. What's that other signal there? So this one is also minus a little stronger. Let's go down. Okay, we're right in the zone where maybe the sound is being transferred through the crossover. Let's go lower. Okay, you kind of bet this would be delivered only to this one, mostly anyway. Is that minus 18? I think that is on the scale. I don't know. Okay, let me try the good old biological technique here. Oh, I'm using two different ears. You know what? It's just as confusing as a microphone. Let's go lower yet. Maybe I'm just not low enough in frequency. Okay, so that's 300 hertz. For sure they want that here and not in those side speakers. So I will use once again the biological test instrument. Nothing. I get nothing here. Nothing. Okay, so now we got a place to start. I'm going to hang the microphone over the tweeter here. Actually, I'll do the other one. The other tweeter is just a little lower in the cabinet. That's another thing. They're not the same height, which is kind of weird. This is not going to hang easily where I want it to. Okay, that's pretty close. So what I want to do is raise the frequency up and see when this speaker comes to life. Now, of course, it's the microphone's picking up some of the main speaker sound, but I think I got to keep the main speaker in there. Oh, okay, hold on. So these are my usual microphones here. I'm turning these ones off in favor of the single one. It gets a little tricky to talk at the same time with these microphones the way they are, but the whopping hum there at 60 hertz and a tone at 300. A little bit confused here with which. This is what's confusing me. There's just too many knobs on this thing. So that's what's confusing me. Let's try this again. We'll just have the technical microphone on. Yeah, big whopping hum there. Where's the 300? Oh, yeah. Right? No 300. That's right. So one of the important factors when you're using microphones is to have them switched on. So now it's switched on. Let's try again. I'm going to go back down to 300. Okay, so you see the 300 there, but the 300 is probably leaking from the main speaker. The interesting thing here is when I use my ear, my brain comes right along with it, but this microphone's got no brain in it, and it's stupid compared to me. I'm smarter than a microphone. So using my ear, I get a lot of information. Using the microphone, I don't get nearly as much. I think that's what I'm learning here. Let's go ahead and try this now. What I'm hoping to see is that as the frequency goes up, at some point, the speaker comes to life. Well, I would say it's somewhere right in the frequency, right around where it is now. Where are we? We're around 1,000 hertz here. So it looks to me like around 1,000 hertz, the speaker we're listening to starts coming to life. It's not very convincing, is it? Okay, I'll move this. I don't think this is going to work out to prove anything, but that's crazy. Okay, so the speaker on this side is this high, and the speaker over here is this high. My microphone is way off over here. I need a much bigger box. Okay, for what it's worth, let's try this out. I'll take it down to 300 and then we'll come up and watch for some kind of a change. So once again, I think it's right around 1,000, maybe 1,200, somewhere right in there. That's what it looks like doing this test, but goodness knows if this is a valid test. But I am now going to use my brain-powered flesh detecting system here and see what it sounds like to my own ears. So just bear with me while I do this. First thing I want to do, put my head right here. I can hear this speaker quite clearly then because my head's right here. And as I raise the frequency, if the sound suddenly starts coming from out here, I should be able to detect that using my fantastic brain-connected audio detection system. There we go. Okay, and I'm going to position my head here. So it sounds like it's here and nowhere else when I do that. It's never a time where it doesn't seem to be coming from here. Okay, so another way to do this. So, numerous times I've fooled around with radios of this sort, and I've almost always found that the tweeters just don't add anything. Maybe they add something to the sales price of the radio, but they don't seem to add much to the sound. And a lot of these style of radios, European style radios, have electrostatic tweeters in them. Not these. I mean, the good news is it's all working. It all appears to be working. These coils, I don't think they can be doing anything other than what they've always done. It's just a coil of wire. How can it wear out or change? I don't think it can. So I think we can be pretty reasonable to expect all this to work just fine. There's no capacitors involved. That's really what I wanted to say. How can I tell a difference? You know what I could do? I could short out these speakers and remove them from the circuit and leave only this one and flip it back and forth, and maybe then we can perceive some kind of change. So I need a switch. I need a switch. This is not switches. I need a switch or some quick way of doing this. There's a beauty. Oh, it's got too many screws. I can't be sure which are which. Get something simpler. Get out a voltmeter, find out what's going on with this. That's a better way. Get out an ohm meter and find out what's going on. Okay, hold still meter. Short. Okay. Double pole, single throw switch. Just as I might have imagined. Put this on with clip leads. Now, how valid is this test? I don't know, because I'm changing the circuitry here. And when I remove these speakers, I'm removing the speakers, the coils, the load that they represent. So this might be really quite a bogus test, but let's try it. You have to try these things. Remember, the bad ideas lead to the good ideas. You've got to let the bad ideas come, because there's a lot more bad ideas. Okay, so you get all the bad ideas out there, and the good ideas start showing up. The first idea, it's almost always a bad idea. Well, this is a bad idea. I hooked it up wrong. I shouldn't talk. I should not talk on these videos. Did I hear applause just now? I don't hear anything. Let's try a higher frequency. This is where we would expect something to happen. So if you look at the chart very carefully, I'll be quiet when I do this. And a tiny little change. A tiny little change. Let's go up higher in frequency. From 1,000 we'll go up to, not that high, 5,000. 5,000 hertz. Okay, so which is which? Tweeter's missing. Tweeter's in. So it's a little tiny bit more. Now, I can't hear it with my ears. Let me try again. Now, let's go up higher yet. Okay, this is 9,000 hertz. I hear it. Actually, it's about 8,500 according to the computer. Literally no difference. So what are these speakers for? They don't seem to be adding much to the game here. It's quite possible when I put the short in place, it changes the dynamics of the circuitry here enough that the result is invalid, and I'm not seeing things for what they really are. Well, let's try this. We'll just do away with these speakers completely. Okay, so I just tipped my head a little bit, and from this position of my head, I can distinctly hear more tweeter, less tweeter. Quite distinct. But if I just move my head a couple of inches, I can hear the sound go up and down, up and down, up and down. I mean, if you do this kind of stuff, you know what I'm talking about. It is really impossible to do this at this frequency. I'm just moving my head back and forth. It's just the standing waves are everywhere. Fat chance I'll ever be able to hear a difference between these two speakers. I can hardly hear any of this. So what if, so I mean the good news with all this is everything seems to be working as well as it can be. So now I'm feeding a high frequency right at this speaker. There's no coil in its way. Can I get the coil in its way without energizing the speaker? I don't think so. Because if I bring the coil in, this speaker is right parallel on the coil. So, okay, so just listening to this speaker, sounds fine. Listen to that. So that frequency is just where I become aware of it. It's based on my head position again. No, that's the highest frequency I can hear coming out of this speaker. We'll switch to the other speakers only. I certainly hear it. It doesn't sound louder. It sounds weaker, if anything. For sure. Let's see what's it doing on the chart. Look, just moving my hands around. I don't know, there's too many things moving. I can't stand perfectly still. Let me try it. If I stand perfectly still, does everything stabilize? I'm going to stand where I can see it. Okay, now I'll just move a little bit. And I'll stand still again. Huh. Just goes to show. As I mentioned in the last video, there's a reason why engineers want to test this kind of stuff out in an anechoic room or a soundproof room or a sound absorbent room is really what I want to say, because there are just so many problems with standing waves and everything going on here. You know, your left ear is not where your right ear is. You ever notice that? So they're hearing different interference effects as you're moving around. It makes the sound like it's traveling around. It's just, this is what your brain is dealing with all the time, successfully. Just in the midst of all this nonsense, my brain is still able to tell me the sound is coming from that speaker. But part of that is because I know that's where sounds come from. If I was convinced that sounds came from microphones, I would probably stand here and go, yeah, it's coming from the microphone. And my brain would project the sound as if it's coming from there. I would be quite convinced. So I think. Maybe I need a new brain. What am I going to try next? Low sounds through the tweeters only. And this high-pitched tone, which you may not be able to hear, is just piercing my ears. So let's go down. And does it drop off? Okay, so we're going to go down lower here because we got to start at lower. So starting at 2,000 hertz, just go down and see when it drops off. Well, that's pretty convincing. Look at that, it's right around that 1K 1200. And I'm just using my regular microphones here, which is fine, I think. Well, So that tells me this whole system, what it's succeeding in doing is preventing the low frequencies from reaching those small speakers. And perhaps that's the major concern here, is just protecting those more fragile speakers and not wasting their time with signals they can't reproduce anyway, or reproduce with any volume anyway. And so the low frequencies are kept from the tweeters, but pretty much everything's allowed to go here. It's not quite true, because there is a crossover. So what's all this mean in terms of the radio that goes in here? I think it means I just hook up all the wires the way they're supposed to be hooked up and don't worry about it, because all the speakers are operating. There's no distortion. Everything sounds good. I can't seem to eke any more out of this, so I can stop eking, bring the radio in here, connect the radio up. We'll listen to the radio, fool around a little bit with these speakers. We can do the FM hiss sound, I think. Okay, so I think I've got the receiver connected back to the speakers exactly the way it's supposed to be, although I have not returned this connection, the black wires, whoops, oh, that's not very good, the black wires back to the radio, because I'm pretty sure the terminal is nothing but a spare terminal here. So twisted there, terminal here, same thing. That's what I believe to be the case. Volume's down, switch is off, dim bulb power is supplied. We'll start with AM just because it's easier to hear the noise. There we go. Patience, everyone, patience. This radio when I started was lacking volume. Not anymore. Let's go to FM. I still got problems here. Good. Perfect. I want that hiss. Now we're going to use what I'm calling my technical microphone, and we're going to listen to all these speakers with the hiss going and see what they sound like. I think this is a much easier way for human beings to get an impression of what's going on here. The volume drop off. Boy, oh boy, I'm going to have to really work on this switch, because clearly I didn't get it. Headphones here. Okay, first of all, big speaker in the front. Okay, what I get out of that little test is, when listening to a hiss, these two speakers sound identical, listening with a microphone, but I'm pretty sure this is a reasonable test. These two speakers sound identical, regardless of how the coils are and all that stuff. This guy seems to have all the sound coming out of it. It seems to me when I bring the microphone over, the hiss you hear from here simply becomes a more expanded hiss. It's more low, rumbly, bassy, maybe not rumbly, but lower sound. So that's my complete conclusion here is the whole operation is designed to make sure the tweeters don't get hit with a big woofer whoomp, and to protect the tweeters. That's what I think is really going on here. And you know, having these or not having these, how much difference can it really make? So let's see if we can figure that out. Go back to using the switch, or there's another easier way I can do it just by moving clip leads here. Yeah, let's try that. I won't engage the switch. We'll go back to this microphone. I'll put it in a neutral spot. Now, I mean, these speakers are all facing out in different directions. Where's the neutral spot? Right here, I guess. Let's stick it in here. Just stick it. We'll just stick it there to start, anyway. And switch to it. So the microphone's touching my bench top, and I think some hums are being delivered through the. Let's find out. Not really. Okay, so what I want to do is play the hiss and then turn on and off the tweeters. And that's essentially what I'm trying to do here. Play the hiss. Well, I can't hear any difference whatsoever between that. So I'm going to attribute this to a little bit of over-engineering, a little bit of salesmanship, a little bit of we've got 3 speakers in our radio and that other manufacturer only has 2 and stuff like that, and maybe all the coils are hooked up just to confuse people. I've had this button pushed in the whole time, but this I discovered before jazz kind of lets through the most. You know, I never checked these. Oh, cheapers creepers. Son of a gun. Whoops, little mistake there. Oh, just here, just in this last area. Not much bass in there to hear. Okay, so I'm back on this microphone again. Okay, treble up full. What happens if we get rid of the tweeters? So I can hear a slight difference there with my, I can hear a slight difference in the headphones here. Can I hear it just without the headphones? Let me try that. So kind of the way I see these kinds of things is you go through them once pretty thoroughly like this, just goofing around and just trying everything, and then once you've gone through something like this once, you don't have to do it again. You've learned what you're going to learn. And now that's in your back pocket, in my case, for about 3 weeks before I forget it all. Can we hear any difference with my ears? Yeah, very same. Very, very same as with the microphone. Okay. Now, let's tune something in here.
He was finished. God said, I'm not going to put up with this anymore, and you're not going to be king anymore, and none of your sons will ever sit on the throne in Israel. I'm going to get me a new king. And the scripture says it this way: the Lord sought out for himself a man after his own heart.
A man, eh? what happened there? So I can only play music for just a few seconds, or I'm going to get a copyright hit. Hey, you know what? That speaker... That's right, I haven't posted a video I thought I posted. So I have done a video, I got a copyright hit for a song called Audio Generator. And I guess in the song they must vary an audio generator up and down, and that's what I was doing here, and they've decided that what I was doing here is really their song. I have a copyright hit on it, and I'm disputing this one. So we'll see what happens. The dispute, they've got 30 days to respond to my dispute. Basically telling them that, hey, it's my original audio generator sound. What are you doing? Isn't that something? You think, no music. How can it possibly get a copyright hit? Because somebody was smart enough to put a song out called Audio Generator. I should try to find that song and listen to it. So let's go back to the music. I have to tune the radio really on the mark to get the best quality sound. It's really quite requires a lot of precision.
Still there.
Good.
You're going to
Talking.
get some hate mail. All right, you hit 721 Rock with your phone calls. What's your name?
My name's Jeff.
Okay, and the name rival for Jeff is...
The other spelling of Jeff.
Oh, with a J? With a J or a G?
G-E-O-F-F.
G-E-O-F-F. Yeah, G-off.
Yeah. And do you never get along with the G-off, do you?
No.
No. Oh, I don't understand that one. Why they spell it that way, I don't get it.
It's sophisticated.
I don't get it either.
So when the music was playing and I advanced the bass, I started hearing some distortion in the bass, some almost sound like a loose connection kind of thing happening. So I'm trying to hear that again, but now they're talking and they don't have quite as much bass in their voices.
Or M-E-R-R-Y, the Merry Christmas. I've had Marlin, Merlin, and Marilyn.
Merlin the magician.
Easy and free. Two of the sweetest words in the English language. Download more than 400 radio stations, including Rock 95, all in one app today. Free and easy. That's Radio Player Canada, where Canadian radio plays.
For over 60 years, Lineman's Testing Laboratories, or LTL.ca, have made their spark in the electrical industry, specializing in compliant, turnkey, high-voltage electrical services. More specifically, LTL.ca delivers cost-effective high-voltage electrical systems, managing the complete program from engineering design, procurement, and installation. All done in-house by certified engineers and technicians. Lineman's Testing Laboratories, your high-voltage electrical partner. Visit LTL.ca.
Dirt into control.
Powerful stress.
Dirt into control. Lineman's Testing Laboratories. I've been there. Because guess what? All the various hats I wore when I worked for the power company for a while, I was the supervisor of the high voltage glove testing lab. We were directly in competition with this organization you just heard advertised here. I mean, I worked for a public utility. We had our own testing lab for gloves for our linemen. We had about 300 linemen. So it was an ongoing, everyday thing. Hundreds of gloves being tested every day. Hundreds? Yeah, I think so. Every day. You had to turn them around every 30 days. They have to be tested. But what are they being tested for? You know, linemen are wearing rubber gloves. Some of them come way up to here. And this rubber glove is what is going to save their lives. For two reasons. One, sometimes they actually handle live conductors right in their rubber gloved hands. They don't like to do that, but sometimes that can be done. But mostly it's when a mistake is made and what they think is dead turns out to be alive, and there they are, and all they've got to save their lives are these rubber gloves. The rubber gloves can get a pinhole. These guys are working with tools, right? They're slinging tools, sharp things. They have special leather covers and covers. Look, I'm sweating here. Getting excited thinking about my past life. And still, there's a chance something pinhole will pierce the glove. Before they do their work, there's a technique they use, or they take the glove, you can imagine this, you blow a little air into it, you seal off this part of it, and then you squeeze it like this, and it makes the glove fingers come out, you examine, you look for cracks, you do all this kind of stuff because the lineman's life depends on this thin film of rubber. So it has to be tested every 30 days to prove that they are in good shape. I might as well tell you how it's done. You take the glove, you hook it in a jig, and basically some clips hold the glove, so the glove is hanging like this. I have some of these gloves. I should bring them in and show you. You hang it in a jig, water goes into the glove, and the glove goes down into a big tank of water. You do this with, say, 20 gloves at the same time. Electrode goes in the water inside the glove, and the water outside the glove is the other terminal. And you raise it up to a set voltage for a set period of time. And if any of those gloves has a pinhole, you find out right away. There's a bang, and the equipment shuts off, and a light comes on, tells you which of the gloves have failed. That's done every month, and every time the gloves are used. The people using them have to test them and check them, because their lives depend on a thin film of rubber. I mean, I don't know if I could be a lineman. I really don't. I don't know if I could. And that is a dangerous job, up on ladders, everything. Oh my gosh. My hat's off to all linemen everywhere. And women, line women. There are some women doing this stuff. Okay, I got a little extra excited there about the rubber glove thing. Where are we at now with this? So, dirty controls, dirty switch, dirty in the front. You know, it's dirt time for this radio, so I'm going to concentrate on cleaning everything up, including those switches, including these controls, try to get everything sorted out. And tomorrow, assuming we're going to work more on this guy, everything should be in good shape then, and these little fiddly problems will be gone. That's what I want to do, so we don't have mechanical type problems in the way. I still need to check the alignment. We know the speakers are fine. Great. Thanks a lot for watching, and see you soon.